There is a realm beyond that known to most technicians, a place that appears unreal, and yet is as real as any repair shop. A place that might be called the Tech Zone. Introducing Mike Clark, a skillful and competent service technician who's about to improve his understanding and use of multimeters in Honda's Tech Zone.
It looks like another day of electrical problems. Oh, what's this? Looks like a new full-cycle program. Multimeters. Practical techniques. Hi. Still trying to fix that motorcycle I see. Wow! Good thing I still had my helmet on. Oh, so this is Honda's Tech Zone. I thought you needed a video player to get here. Not quite. Well, that's great, but I have to get back to work if I'm to make any money today. How do I get out of here?
Hold on a second. I think you should spend a little time here. I've seen your work, and you're not getting your money's worth out of your multimeter.
Well, I've been using it to measure battery voltages and some component resistances. What else is there?
Well, for one thing, you may not be testing these components completely. In fact, over half the electrical components returned to American Honda from dealerships test out good. And there's lots of other things you can do with a multimeter. If you stick around, you will learn how to set up a digital multimeter for operation. Use a multimeter to test voltage and amperage, including testing with the 200 amp shunt. You'll also learn how to test resistance, including using the CDI function of a digital meter. Of course, before you achieve these objectives, you have to understand both digital and analog multimeters.
Wait a minute. Why should I have to learn about both?
Well, they both have their advantages. The analog or needle type costs less, but it isn't as precise or easy to read as the digital type. But an analog meter makes it easier to check varying voltage and resistances. For example, if a customer complains of an erratic fuel level, one of the procedures is to test the fuel level sender. You should get a reading like this. But since there are other full-cycle programs about how to read analog ohm meters and voltmeters, we're going to concentrate on all the functions of the digital meter and the analog meter's 10 amp scale. Now let's go on and learn how to set up a digital multimeter for operation. When you're setting up a digital multimeter for operation, remember all its functions are battery powered. This arrow means the battery is low and should be replaced. If the meter isn't working and you know the battery's good, then check the fuse. Once you've got the meter operating, here's a sequence you should go through each time you take a measurement. First, plug the leads into the right socket for the test you want to do. Next, pick the function and range of the meter needed for the test you're going to make. Then connect the test leads properly. In many tests, the polarity of the leads is important. And that's how you set up a multimeter. Now, let's do some testing. Regardless of the kind of meter you're using, the method of testing voltage is the same. Have you watched the full-cycle program called The Basics of Electrical Troubleshooting?
Yeah, I've seen that program.
Good, because you need to understand the electrical concepts presented in that program in order to utilize your meter fully. You'll remember that voltage is merely a way of expressing the difference in electrical pressure or potential between 2 points in a circuit. A voltmeter can measure this difference, but remember, you have to connect a voltmeter like this. Just in case your skills with an analog voltmeter are a little rusty, let's quickly review reading an analog meter's scales. This is the 15-volt scale. It's the scale you use the most because it gives you the most precision when you're measuring voltage in a 12-volt system. Can you tell how much voltage the meter is reading here?
Let's see, it's on the 12, and the first mark is 0.2 of a volt, so it's 12.4 volts.
Right. Sounds like your skills are still pretty sharp. And to make them even sharper, there's a job aid supplied with this program that goes into more detail about reading and interpreting various scales on an analog multimeter. Now we'll take a look at the voltmeter function of the digital multimeter. To read voltage with a digital multimeter, plug the black test lead into the COM jack and the red test lead into the VOMs jack. The next step is to pick the right function of the meter for the measurement you want to make, DC volts in this case, and then select the proper voltage range. Let's say that on this motorcycle it turns over, the lights work, but it won't start.
Okay.
Why don't you go ahead and test it and I'll explain to you what to do.
All right.
Since you're working with a 12-volt system, you use the 20-volt range. Make sure the selector is on the mark. If it's between the numbers, you'll get a false reading. Remember, with direct current, like a battery has, you'll need to get the polarity right. If you see a minus sign like this appear, it means that you've got the leads reversed.
Oh. The battery reads 12.32 volts, so it's okay. Well, what do I check next?
Check the ignition fuse next.
Okay.
First, connect the negative lead to ground. You should get voltage on both sides unless the fuse is open.
Ah, so the fuse is bad.
Right. Using a voltage meter is the quickest way to check this kind of fuse.
What happens if I use a lower range than the voltage I'm testing?
Switch it over to the 2-volt range and see what happens.
Okay. Now what's that?
Well, that 1 means that there's too much voltage for that range to read.
Oh, so whenever that happens, I switch it to the next higher range, right?
Right. In fact, when you're not sure what the voltage you're testing is, always start with the highest range and work your way down. Now let's check out the AC function. The AC voltmeter measures alternating current. It works the same way as the DC, only you don't have to worry about polarity when you're connecting the test leads.
So if I have a motorcycle that's not charging, but all of the components check out okay, I could test to see that all 3 stator windings have the same output.
Right. Try it out on the GL1200.
Well, what am I looking for?
First, connect the negative lead to ground. Then compare the voltage output of each stator winding.
Well, they all check out equal, so this stator's okay.
Now let's go on to the ammeter function. Oh, and here's a very important tip. A lot of meters are destroyed because technicians forget to disconnect them from the circuits when they're changing between different functions. For example, volts and amps. So make sure to disconnect your meter first. You use the DC ammeter function to measure the amount of amperage in a circuit. There are a few precautions you should remember when using it, though. First, remember that amperage testing is done with the meter hooked up in series with the circuit. That means all the current the circuit is drawing is also running through the meter. If the amount of amperage in the circuit exceeds the rated capability of the meter, you'll destroy it. So it's important that you use the correct jack and range selection for the test you're doing. Let's do an amperage measurement on this motorcycle. It's been stored for a year and the sales department wants it checked out. It's got a new battery, but we'll need to check the electrical system to make sure it's all right. It'll be a good chance to use the 10 amp scale on the analog meter too. What's the first thing you do when measuring amperage?
Well, first I connect the test leads to the proper jacks. Then I select the proper meter function, and then the right range. Then I connect it up for the test.
Right. In this case, we've removed the main fuse and used its terminals for our series connection.
Well, the key's off, and there's no current draw.
How much amperage is the ammeter reading now?
Well, this scale reads like the 15-volt scale, so each division is 1 amp, and the small divisions are 2/10 of an amp. So this motorcycle draws 7.3 amps. What about the charging system? Can I check it too?
Yes, when the charging circuit is on the main fuse, you can just reverse the leads. Don't forget to let the motorcycle run for a few minutes to let the battery recover from the starter draw.
I see. At about 1,300 RPMs, the charging system's output equals the motorcycle's current draw. That must be the break-even speed. Yep, the RPMs match specs. And it's charging over 5 amps at 5,000 RPMs, which also meets specs. So the charging system's all right. But what happens if the charging system isn't on the main fuse, or the motorcycle draws more than 10 amps, like on the GL1200?
That's when you need this Honda-approved 200 amp shunt. It's designed to be used with a digital multimeter. Connect it between the negative terminal and the negative battery cable. Set the selector for 200 millivolts.
Millivolts?
Right, millivolts. That's what the directions say. You can check out the job aid for an explanation of how it works.
So where do I connect this thing?
Plug it into the voltage and common jacks. With the 200 amp shunt, you can measure the current draw of the electrical system, the starter's current draw, and the charging system's break-even speed and output. You'll need to compare your results to the service manual specs.
Hey, this 200 amp shunt could really come in handy.
I knew you'd see its value. Now let's go on to the digital ohm meter for testing resistance. An ohm meter is like a self-powered test light because it has its own power supply, and it can test for opens or shorts, but it can also measure how much resistance a circuit or component has. There's one important precaution to remember when you're using an ohm meter. Never connect it to a live circuit. You'll destroy the meter. Always make sure the power is disconnected. If you think a circuit might be hot, check it with a voltmeter first. Whenever possible, isolate the component you're testing from the rest of the circuit, or you might get a false reading because of other resistances on the same branch. When you measure resistance with a digital ohm meter, you'll find that it's a lot easier than with an analog ohm meter because you don't have to interpret scales. When the ohm meter is reading low resistance, zeros will appear in the display. When the test leads are separated, or when the meter is reading infinite resistance, you'll see a 1. Digital ohm meters can read very low resistances precisely. Notice that when it is set in the 0 to 200 ohms range and the test leads are shorted, it will actually show the resistance of the leads themselves. After hooking up the test leads, the next thing you do is
To select the function and range you intend to use.
Right. Each number on the face of the ohms range of the scale represents the maximum resistance the meter can read in that range.
Just like the voltage scale, right?
Right. If this motorcycle had an ignition failure, one of the tests you'd do is check the coil's resistance. First, check the secondary side. If you try to read a greater resistance than the range you've selected, the meter will show an overrange condition.
It reads 18 k ohms, and that's within specs.
Now switch the meter to the 200 ohm range and let's test the primary circuit. In this range, the number to the right of the decimal point represents tenths of an ohm, so
it's reading 0.7 ohms. That's within specs too.
of course there may be other tests you'll need to perform before you give the coil an OK. There's one more function of the meter to show you, and that's the CDI test function used for testing diodes. If the customer complained that the neutral light came on every time the clutch lever was pulled in, you check the starter switch diode. The CDI function will measure the different resistances in each direction, which the normal ohm meter function won't do. If this diode had been bad, it would have read either high in both directions or low in both directions. Well, that pretty well covers the different functions of multimeters and how they're used. So let's go over what we've covered since you've been here.
Well, I've reviewed reading analog meters, And I've learned how to set up a digital multimeter and check and replace the battery and fuse. I've also learned the 4 steps I should follow every time I do a test. Plug in the leads correctly for the test I'm doing, select the appropriate function and range, connect the test leads properly to the circuit or component I'm testing, and do the appropriate test. I know how to use a voltmeter to test both AC and DC voltages.
And you've also learned how to connect both kinds of ammeters to a circuit to measure DC current.
Yeah, and now I know how to use a 200 amp shunt with a digital multimeter, how to set up and read a digital ohm meter, and how to use the CDI function to test diodes.
Once you know how to use a multimeter, you're ready to perform virtually any electrical test that's called for on a Honda. And you'll be able to do it quickly and accurately.
Hey, I'm convinced. So how do I get out of here? I want to try this stuff out back at the shop. Oh no, not again!
Submitted for your approval, Mike Clark, a service technician who didn't have time to learn the full capabilities of himself or his instruments. Didn't have the time until he took a brief but useful journey into the tech zone.